Good evening, everybody. Thank you so much for being here. Thank you for the warm welcome. I have never spoken to such a large ISSA chapter conference before. It's an honor. I have been a member of the Silicon Valley chapter. I think their meetings generally run about half the size. I have written for ISSA Journal. I have spoken at their conferences, but today's honor is very unique. Thank you so much. Normally this is a 1-hour presentation if I go at 75 miles per hour, but given that I've been told I have about 40 minutes at most, fasten your seatbelts. I'm dispensing with all stories, all jokes, and any anecdotes. We're going to get right into the technical content. You are technical people, and this is going to be it's not deep technical stuff, but it is crucial. It is going to be crucial to your careers. That is my opinion, but I think if you research it, you will find out that it is a tsunami that is coming to you. Just a very quick question. How many of you know the acronym RACF, R-A-C-F? Okay. Resource Access Control Facility. A software module on IBM mainframe systems that I first ran into about 35 years ago, and first came when I got into the field and came across user ID passwords. And I thought IBM introduced this whole concept of authentication using passwords. But in order to confirm this, I reached out to someone I read about who was one of the developers of RACF and just asked him, when did you actually develop this, and was this the first instance of the use of passwords on IBM mainframes? And he said, oh no, they've been using it for years, maybe more than a decade on mainframes long before RACF. So, which led me to calculate that user ID password authentication was invented probably in the 60s at some time. That's more than 60, almost 70 years ago. What are we doing with this authentication scheme in the 21st century? It's like using rabbit ear antennas on your ultra-high definition TV. That is what we are doing. And it is a form of authentication schemes called shared secret authentication. You know a secret, the resource you're trying to access knows your secret. Whether it's hashed, mapped, encrypted, whatever, it is shared with that computer. It represents a scalable attack. Why? Because an attacker only has to compromise that database once, and they have compromised everybody's password on that system. Every authentication scheme that has come after that, termed MFA, 2FA, what you know, what you have, what you are, they are all forms of shared secret authentication, whether it's OTP, SMS, KBA, I don't care what you call it. They are all shared secret systems. RSA, the company, bought a company called Secure ID. I don't know how many billions they paid for it. They couldn't secure the seeds of the tokens that they had shipped to some of the largest companies and governments worldwide and shut down those companies for more than a week in order to ship out new seeds to those tokens. But they're still in use today. Billion-dollar companies are still using passwords today. That is the problem, one of the most fundamental problems we have with security on the internet. Not here to bash passwords anymore, but we should bury it. We should bury it. Public key cryptography is the first technology that was invented more than 35 years ago that broke the model of shared secret authentication. The computer you're trying to access has no secret. It only has a public key. You have the private key. The server challenges you randomly. You digitally sign it. Anyone can see the digital signature. Anyone can see the challenge. But as long as you own that private key and protect it, only you can digitally sign it. And the server verifies the signature, determines and authenticates you, and you now have access to the computer. 35 years ago, this technology was introduced. PKI was the public key infrastructure, was the scalable asymmetric key cryptography authentication technology that was born out of it. Large companies invested in PKI more than 25 years ago. We use digital certificates today on the internet. Every HTTPS server uses a digital certificate for server-side authentication, where you, the consumer, the client, authenticates the server. But the protocol, TLS, actually includes client-side authentication, which allows the user to have a digital certificate on the client side and authenticate to the server with a digital signature. Less than 1% of the internet community uses it. It failed. It still continues to be used, but it failed because it is complex, it is expensive, it's very difficult to program to it, very difficult user experience. Long story short, even though the technology is extremely capable of protecting systems, it's not very useful in the consumer sector. That's why nobody adopted it. 5 years ago, an alliance was born called the FIDO Alliance, Fast Identity Online. Quick show of hands, how many of you have heard of it or know anything about it? Okay, much more than the people who know RACF. That's a good sign. But you're going to learn a heck of a lot about FIDO2 today, hopefully in the 40 minutes that I've been allotted, excuse me. Very, very quickly, FIDO Alliance is a nonprofit organization just like the ISSA. Their mission is to eliminate passwords off the internet using asymmetric key cryptography. There are lots of very unique things about FIDO protocols that have never been introduced in the history of authentication before. You're going to hear about them today. They began with two protocols, the Universal Authentication Framework and the Universal Second Factor. I'm not going to talk about them anymore, simply, except for perhaps a one-slide description. Both of those have been superseded by FIDO2, the next generation version, which got standardized less than a year ago. The JavaScript API of the FIDO2 protocol is called Web Authentication, standardized by the World Wide Web Consortium. It's an industry standard, royalty-free, open protocol. There are more than 200 implementations of authenticators and servers, including open source implementations. Many of you are probably even using FIDO2 authenticators and just don't know that it supports the highest assurance authentication technology ever created. Not my words, this is NIST, Special Publication 800-63-3, Digital Identity Guidelines. Go ahead and look for that phrase, highest assurance authentication technology. They recommended this 2 years ago. I can count on one hand the number of websites I know that have implemented FIDO. That is sad. That is sad. It is a technology that can eliminate authentication breaches from the internet or even within your enterprise or organization. As much as FIDO Alliance does their job, as big as it is, some of the largest companies in the world, some of the largest governments in the world are members of the FIDO Alliance. And it is embedded in Windows 10, it is embedded in Android, it is supported on all browsers today. Out of the box. You don't have to do anything, no plugins, no nothing. It just works. But very, very few people are actually using it. Hopefully after this presentation, you'll all be out there rushing and killing passwords for your web application. Hopefully. So, very quickly, Universal Authentication Framework was designed for mobile devices, very capable protocol, and it is a passwordless protocol. The problem with this was that it's a very, very rich protocol, and it required licensing a software module for each mobile device. And because it only worked on mobile devices, it did not help companies who needed to still use a strong authentication protocol on desktops, laptops, and such types of devices. One of the interesting things about FIDO protocols is that they can leverage biometrics, but the biometric template, the synthesis of your biometric, which is the template, is never used in a FIDO protocol. There is no mention of a biometric in the actual FIDO protocol that goes from the client to the server. Why? Because FIDO Alliance began with the premise that the authentication protocol has to be privacy protecting. What does that mean? When you use a FIDO authenticator to authenticate yourself to a FIDO2 server, only that server, the relying party company that built that web application, only they know who you are. That's it. Nobody else knows that you are using a FIDO2 authenticator. However, FIDO2 authenticators that are implemented in many form factors, some of them are USB-style flash drives. They can hold hundreds, unlimited FIDO cryptographic keys. And all of the websites that you register FIDO keys with, they do not know any other key that lives on your FIDO authenticator. If you're using a MacBook, it supports FIDO2 with Touch ID. If you have a Windows 10 laptop, desktop, tablet, it supports FIDO2 out of the box. Every key you register with a website is a unique key pair. Thank you. Is a unique key pair. So every website knows only its own public key for that user. No other website sees that public key. There are no digital certificates, even though they are using asymmetric key cryptography. Biometrics are used only to authenticate the human being to the device, the mobile device. This is called user verification in FIDO2 terminology. The user can be verified, and only then it unlocks the private key in a cryptographic chip on the mobile device to digitally sign the challenge that comes from the server. There are also possibilities to specify policies in UAF, but I'm not going to go into detail. And there is also a capability to get a digital signature for transaction confirmation, whether you're transferring $100, whether you're buying some audiovisual device. The merchant or whoever the website operator is, they can actually get a digital signature from your FIDO authenticator for the transaction. Universal second factor was created through a combination of Google and some other companies. They were working on it as an internal project, and when they joined the FIDO Alliance accepted it as a second protocol, but recognizing that there was going to be confusion, they decided to merge the best capabilities of both the protocols, and that became FIDO2. I'm not going to read out everything here. The one thing you do need to know is that FIDO2, the latest version of the protocol, is backwardly compatible with U2F, but not UAF. And FIDO2 works on all devices, whether it's laptop, desktops, mobile, tablets, whatever that may be. I'm not going to read out too much about this. I mentioned this already. What's common to all of these protocols? First interesting new feature of FIDO, mandatory test of user presence. What does that mean? One of the attacks that we are all very used to is that a website or a resource gets compromised by some attacker somewhere on the internet. And you have no knowledge of it. You have no clue what's going on. And if your systems aren't capturing all of this information, you don't even know it's happened, sometimes for years, as with some companies we know in the press. FIDO requires that any resource, any computer attempting to authenticate to a remote resource, there has to be a human being in front of that computer and provide proof that they were in front of that computer. And how do you do that? With some human action, either a biometric template, a voice print, a fingerprint, an iris image, or even just touching a contact point or pressing a button on the FIDO authenticator. It doesn't matter. Something that a remote attacker far away cannot do. And that is mandatory in all protocols. The second thing that is absolutely necessary is a cryptographic hardware device. Digital certificates have asymmetric key cryptography, but people were starting to use digital certificates in software, protected by a password, storing the encrypted private key on their file system. And if the computer was compromised, so was their private key. And now it didn't matter that you had asymmetric key cryptography authentication to a remote resource. It was compromised. FIDO requires physical hardware devices. FIDO Alliance has also set up certification processes for FIDO authenticators, similar to the FIPS 140-2 levels. And you can actually specify that your website or application will only accept specific types of FIDO authenticators for registration and exclude anything you choose not to support. It's possible. But a cryptographic hardware is mandatory. In fact, Google has gone so far, their latest operating system, a year or two ago, they told their OEM partners, if your phone device does not have a cryptographic secure element, you're not going to be able to install the latest version of Android on it. The corollary of that is, if you have the latest version of Android on your phone, by definition, you have a cryptographic chip on your mobile phone. This cryptographic chip is a secure key store for your cryptographic keys, and it's responsible for the digital signatures that it's producing for the challenges that come from the web server. Highly secure stuff. You can protect access to that cryptographic key store with a biometric, fingerprint, iris, voice, PIN, password, whatever that may be, but the keys are not accessible unless there is local user device verification of the user. Next thing you need in order to use FIDO is a FIDO-aware platform. What is that? It is either an operating system or a browser. Well, that problem is no longer a problem. A few years ago, it was an issue because only Chrome supported FIDO and nobody else did. Today, I've already indicated Windows 10, Android, they already support. Apple is the only holdout, but they are releasing little bits and pieces of FIDO2 support. They put out a developer release of Safari. All other browsers support FIDO2 in production today. Apple released a developer edition of Safari that supports it, and just a few weeks ago, they supported FIDO2 on iOS, their first implementation of FIDO on a mobile iPhone. You need a FIDO-enabled web application. What does that mean? It is a new protocol. It requires programming your web application using specific JavaScript that's defined by the World Wide Web Consortium. If that JavaScript is not in your web application, the web application doesn't know that you're planning to use FIDO for authenticating the human being, and as a result, it would not work. So it does require a reprogramming effort. There are market-driven solutions out there that are trying to address this problem and trying to create FIDO2 gateways, but I'm not going to talk about them right now. But suffice to know that you do need to integrate WebAuthn JavaScript into the web application to be able to use it. Last but not least, you need a FIDO server. Now, if you go to GitHub, or if you search the internet, you'll find lots of open source libraries. The libraries are intended to be integrated into web applications. The problem with that is, in my personal opinion, it puts the equivalent of a FIDO2 server in every web application. The last thing you want is every application managing cryptographic keys for all of their users. What you really want is a centralized enterprise scale, highly available FIDO2 server that can be used by all applications within the organization. But that decision is not a technical one. It's a business decision. There is one other feature that FIDO2 supports, but this is lagging a little bit because the industry ecosystem is just trying to get introduced to the whole concept. A metadata service essentially is the equivalent of a certificate revocation list in PKI. When a digital certificate is revoked, the serial number of that certificate is published in a CRL. Anyone who's relying on a digital certificate is expected to download the CRL and check for that serial number to see if it exists there. If it does, then they know that the certificate is revoked. The metadata service is a way to warn web application owners that particular brands of FIDO authenticators may have a bug or have been recalled or there's some security issue with it, and then they can make a business decision on whether they choose to continue to support it or what they expect to tell their users if they come across that authenticator on their web application. So, at a minimum, these are the requirements to make the FIDO protocol work. Very quickly, a very small side note, if you start learning about FIDO out on the internet, you're going to see lots of definitions of keys over there. Just a very quick note is that platform keys, embedded keys, resident keys all mean the same thing. They are cryptographic keys that are generated, stored in a device that has a built-in platform like Windows or Android. And those keys never leave that device. So you cannot transport a FIDO key generated on one Windows laptop to another Windows device or to an Android device. Does not work. But here's the cool thing about FIDO that no other authentication protocol has ever done before. You can register multiple devices, multiple authenticators with unique cryptographic keys to the same application. What does that mean? I have 3 FIDO authenticators on my keychain. I have a FIDO authenticator on my MacBook. I have a FIDO authenticator on my Android phone. That makes 5 authenticators. I can register a unique key pair on every one of those devices to the same website, registered to the same username account. And now I can use any one of those authenticators to authenticate myself to the web application. So if I lose one of my USB keys, doesn't matter. I use an alternate FIDO authenticator, log in, delete the one I've lost. And if I choose to buy another one as a backup, I register it right there in my profile page that typically has a FIDO key management panel. If I have time, I'm going to demonstrate that. Security keys, roaming keys, non-resident keys are transportable devices that can be taken from one device to another. It has the same properties as resident keys. They just happen to be portable, that's all. There's a lot of confusion out there on the internet. Just trying to give you some basic information so that you can make sense of what the heck you're reading about. It is extraordinarily confusing at this stage of the industry, but hopefully in time it'll settle down. So, what are the types of transactions that FIDO supports? Registration. It is a must. It's like issuing a digital certificate, or it's like enrolling a biometric. Think of it as a one-time process. You register a FIDO key with a website, and once registered, you can use it to authenticate with that key 1,000,000 times. Authentication is also called assertion. Transaction confirmation is supported in FIDO2. So it's one of those features that did come from UAF. It's not implemented in any browser today, however. But registration and authentication are supported on all FIDO2 platforms. Other things that FIDO protocols are expected to do but are not part of the protocol, things like account recovery. What happens if you only have one FIDO authenticator and you've lost that key? How do you get back into the account? The web application owner has to have a process for recovering the account for that particular user. What that process is depends on the security policy of the company, how much time and money do they want to invest, how difficult do they want to make it for the user, or perhaps some attacker who's trying to take over your account. So all of those factors play in what account recovery is. I'm not going to go into details, but it's one of the things you'll have to think about. Deleting FIDO keys is necessary if you lose authenticators. There is no such thing as revoking a FIDO authenticator or a key. It's not a digital certificate with a fixed lifetime. Once a key is registered, it lives forever, unless you choose to suspend it through the FIDO server capabilities that you either build or buy, or you choose to delete it, or the user chooses to delete it. That's it. There is no start date and end date for FIDO keys. You can, of course, get information out of your authenticator provided by tools that the manufacturer provides. There is no renewal of FIDO keys like digital certificates. So what does registration look like? And I'm going to go really fast with this. User comes to a website and supplies a username. Excuse me while I put on my glasses. Provides a username on some browser platform that is FIDO2 aware. The username and a display name. Let's ignore the display name for the moment. The username is sent to the web application backend, and the web application, one of the first things it needs to know, the application has to have been FIDO enabled, which means some programming effort would have taken place ahead of time to make sure that this process, this workflow, supports FIDO-based registration and authentication. If so, the first thing the application is going to do is to check, is this user already registered with a FIDO key? If not, it will then talk to a FIDO2 server and get a challenge from that server, a random challenge for that username. That comes back to the server, which comes back to the browser. And this is where the JavaScript from W3C comes into action. The special JavaScript that was created by W3C for the WebAuthn capability pushes information about that challenge and other metadata down into the authenticator. There are only 3 ways to communicate with an authenticator from the browser: USB protocol, Bluetooth, NFC, unless it happens to be a resident key built into the motherboard or the device itself, like a TPM on a desktop laptop or a secure element. When the authenticator gets that information, it goes through some pre-processing, everything checks out. The first thing it's going to do is going to ask the user to prove that they are in front of the computer. The user must now do some human action with that authenticator to prove to the application that he or she is there. Once that user has provided that, the keys are generated and an attestation signature is created by the authenticator and other metadata, and all of this is packaged in a compact binary protocol that can be broken apart by an attacker if they wanted to, but they're not going to be able to modify it. There is no username information in this response. There is nothing that the attacker can modify because it is digitally signed. Even a change of 1 bit breaks the whole process. Goes back to the server, goes back to the FIDO server. The server may optionally check the metadata service to see if that authenticator is still good to register, and if so, it actually stores that public key for that user, and the user is now registered. Response comes back. There may be application-specific things that the application might do once a user has successfully registered, and the user is notified that they are now registered. The authentication process is almost identical. The only difference is that they must now have an authenticator to authenticate themselves. If they do not have that authenticator, it is impossible for them to get into the web application. They have to have that very precise authenticator, whatever that may be. whether it's an external security key or whether it's a specific desktop or laptop. Once they identify themselves, and they don't necessarily have to type it because a cookie is acceptable that could pre-populate the login screen. The username goes back. The application checks to see if the user is FIDO2 registered, and the user would have to be registered to authenticate, in which case it now gets a challenge for authentication from the FIDO server. Comes back all the way back to the authenticator and now gets a test of user presence again. Every single time there's an authentication, there is a test of user presence. There is no fudging. There is no shortcuts. Every single time FIDO authentication requires a test of user presence. You may think that's annoying. I don't want to keep touching the MacBook Touch ID. I don't want to keep typing in my PIN. But this is designed to break the problem that we've been living with for the last 20 years. How many times, how much money, how much effort has gone into trying to secure passwords, educate people, change password policy? Oh my God. I've stopped registering at websites because it's using user ID password. I don't care. I won't buy from e-commerce sites. I'll walk to the nearest grocery store to buy stuff. I don't care about my points on airlines or hotels anymore. I reached platinum status on Marriott after using them for 25 years, and they got breached. I walked away from them overnight. Overnight. Started all the way at the bottom. Who cares? My privacy and my principles are more important to me than the silly rewards that they think they can give me. But they're treating me like an idiot. That I am so stupid that I cannot deal with something as complicated as a silly USB. Do I still need to be treated like a child that I can only deal with passwords? That is patronizing. That's the best I can say. Thank you. So the authentication response, if it is successful, will come back to the application. The digital signature has to be verified correctly. There are all kinds of controls on the server to make sure that the challenge is correct. It is timely because it has to happen within a certain short window when the challenge was generated. So there are lots of security issues with FIDO2 servers. The internet may make it seem like, oh, it's so trivial. You just write some little code or download this library, and lo and behold, you have a FIDO server in your web application. You don't need to do anything about it. Don't believe a word. There is a vulnerability in the FIDO protocol that nobody knew about until we brought it to their attention. And they decided it was not a protocol issue. It is an implementation issue, and as a result, the server manufacturer is supposed to deal with it. How many server manufacturers are going to tell you about it? Only the ones who have addressed the problem. We're going to hear about it today. Registering another key. I've told you already that FIDO allows you to register unlimited number of keys to a particular website. This is to protect you, so that if you lose one, you have another one. You can buy one FIDO authenticator, stick it into your computer at home, and everybody in the family can use the same authenticator to different websites. How? Because the authenticator, unless it's using a biometric to authenticate the human being, which the vast majority are not, many of them are simple. For $10, you can get yourself a secure FIDO authenticator that only requires touching a contact point. But it can store unlimited numbers of keys as long as the website supports FIDO. Everyone in the family can use the same authenticator to register a key to a different website. All the keys are unique. Their usernames are likely to be unique. And as long as that authenticator is in that computer, everybody's privacy is protected, and their authentication credentials are protected. So you can have one at home, you can have one in the office, one on your keychain, one in a backup safe, do whatever you want. But in my personal opinion, in a few years from now, every human being will be carrying 3 FIDO authenticators on their body at all times. One in their keychain, because automobile manufacturers are most likely to go to the FIDO2 protocol in the key fob to get you access into the car. Credit card, all the credit card issuers are board members of the FIDO Alliance. What do you think they're doing? They're putting the FIDO2 protocol on the smart chip of their credit cards. Why do you think they're doing that? Because they want to authenticate you strongly anytime you use that credit card at an ATM or in some place where they don't know whether they can trust you. The third is more than likely your company credential. At some point, this tsunami is going to go across your company. Why? Because you don't know this, but Google has supported FIDO for the last 4 years. How many of you are using FIDO to protect your Gmail account? 4 hands, 5 hands, 6 hands. Facebook has supported it for the last 3 years. Twitter has supported it for the last 2 years. PayPal has supported it for the last 4. Bank of America has supported it for the last 2-3 years. They're not advertising it. Now, maybe there's some business issues. But the the people who are dealing with your data, it's a disincentive for them to advertise that they support FIDO. Why? Because it slows down the authentication, slows down how much money they earn from the moment you log on to their website. Notwithstanding that, you can buy a $10 authenticator today, and you can lock down your account on all the websites I told you, and you can go outside your house and write down your username and password to those websites. And nobody's going to be able to get it. Trust me on this. I've been working in public key crypto for 20 years, and I've verified this. Registering additional keys is no different from registering the first one. The only difference is you have to have authenticated with a FIDO2 key before. And transaction confirmation is not supported today, but the intent is that the web application has a way of condensing the transaction, sending it to the FIDO2 server, which generates a unique challenge for that transaction. And, that transaction gets digitally signed. That challenge gets digitally signed. And that becomes your proof that this transaction did occur and only that user could have committed to that transaction. Our server is open source. It's on GitHub. It's been out there. We have FIDO certified it. What does that mean? It means that we have gone through a testing process and we have validated it against a test suite that was created by the FIDO Alliance. To the best of our knowledge, it is the only open source FIDO2 server in the world today. It is enterprise scale. It includes high availability built in, so you can create a cluster of FIDO2 servers and you will have high availability and disaster recovery. No per seat licensing. Few other things that I'm going to talk about because I know we're running short of time. You need to know about this. It's a privacy protecting protocol. I already mentioned that. But here is the problem. And graphically, you have Jack and Jill. And they have registered themselves to the same website. And you can see something there called a key handle. Ignore that for the moment, but there's the public key for Jack and Jill. Now, what happens if the FIDO2 server is just using a relational database, which most of them are likely to be using if they're hosting tens of thousands or millions of users? What if a SQL injection attack, what if a vulnerability to the passwords of the database schema allows an attacker to go in and add or modify records in the FIDO2 server? In this particular attack, Jack has replaced, take a look at this. Jill's key handle was Cafe Babe and public key was ABCDEF. and that's just my representation. The keys are actually huge. But what Jack has done is he has changed it and replaced it with his own key handle and public key. And now what happens when Jack uses his authenticator and uses Jill's username, he gets authenticated into Jill's account. Why is that? Because that's the FIDO protocol at work. When the application sees Jill's username coming from the web application, it's going to go look up Jill's record in the database, finds this information. The protocol requires sending the key handle back to the browser and goes back into the authenticator. But now, whose key handle is going back? It's Jack's. And Jack has his own key in his key authenticator. He's going to be able to produce a valid digital signature because the public key in Jill's account is his public key. He's replaced it. So now the digital signature is verified correctly. He's authenticated, but under whose ID? Jill. The application now gets back a success response from the FIDO server and now assigns Jack to whatever roles Jill has in that application. But if all he does is replace his key handle and public key with his own, he's alerting Jill to the fact that something's gone wrong with her account. And she's going to raise an alarm if something happens. But what if he adds his key to Jill's account? Because remember, FIDO allows a user to register any number of public keys with commensurate key handles that go along with it. You don't have to know how that thing works. The authenticator does that stuff for you. But when there are additional keys in Jill's account, Jill's going to be able to use her own key to authenticate, so she doesn't realize anything has gone wrong. But Jack now also can authenticate to Jill's account, and she doesn't know it. The logs are not going to show that it's Jack who's authenticating into Jill's account. The logs may show only Jill has sent an authentication request, a challenge went back, a signature came back, verified correctly, and Jill is authenticated. Not unless the logs are printing a whole lot of information about the key handles and public keys, which most FIDO servers will not do because that log will become too huge to manage. How do you protect this? Clearly, the protocol should have been able to do this. But unfortunately, the FIDO Alliance can't break the protocol anymore because there are too many implementations out there, number one. And number two, it's privacy protecting by design and principle. They cannot put the username information in the response, the binary response that goes back to the FIDO server. Because now that would tell anyone in the middle, this is John's public key. This is his user handle. This is his key handle. And remember, even though the protocol itself is secure, the implementations of the authenticator may be weak. Someone may have used a very poor implementation of a security chip, and even though it's using elliptic curve DSA, 256 bits, which is a very strong cryptographic key, if the implementation is bad, perhaps there could be a way to discover the private key of that particular user, simply by looking at the key handle or identifying other pieces of information from the data that flows back and forth. So the only way to protect against this outside of the protocol is you have to digitally sign the transaction record at the first time a user registers a key. If this record were digitally signed, if there were a digital signature associated with that particular record, if anything changed in the database outside of the web application that was authorized to make those changes, that digital signature would break instantly. That is what we've done, and anytime there is a digital signature that's broken in a FIDO record, we don't use that record to send back a challenge, period. Because if I've got 5 keys registered to my account at a particular web application, I get back 5 key handles and 1 challenge. I can use any one of my 5 authenticators to digitally sign that challenge. The key handles are a way to tell the authenticator manufacturer how to identify the private key inside that device so that it can tell whether it belongs to that particular authenticator or not. Because there are going to be attackers who are going to try to attack your account with whatever authenticator they think. If they don't know enough about FIDO, they're going to try using whatever authenticator they have and try to use it against your account at whatever website they may have. They may use the correct name, John Doe, and they'll get back a whole list of key handles and a challenge. But they're not ever, their authenticator, if it was manufactured correctly, is not going to find that key handle information in the authenticator, and it's not going to do anything. If the attacker was smart enough to have built their own authenticator, they're still not going to have the private key to that public key to digitally sign it. If they made up a private key and digitally signed this thing, it's going to get rejected on the server side. Not unless they know how to break public key cryptography. We won't worry about quantum key computing, at least for a few years, hopefully, but I'll be back at that time. So, one more important thing, and then I'm going to just open it up for questions. I know I'm rushing through this very, very fast. A lot of us are already used to identity federation, single sign-on. It's been a convenience because we hate passwords. We hate the number of passwords we have, and we would like to see them dead if we can. And so SSO was a way to solve the problem. There are identity providers, there are protocols that address this problem. It's a great convenience, so it would seem. But how does it work with FIDO? If you go to FIDO Alliance's website, technically they'll say, we work with federation authentication. And we work with IDPs, we work with OAuth2, we work with SAML. We don't do anything. We're only focused on the authentication part. We authenticate the human being, and then we hand it off to whoever's dealing with the authorization part. And if they have to produce a SAML token or OAuth token or do whatever it is that they do, JWT, that's their business. We're only dealing with the authentication problem. The problem, however, is, apologize for the rather complicated picture, but an IDP does not serve one customer, not unless it's an internal identity provider for an enterprise or a government organization. If you are a large enterprise and you have hundreds of web applications and you built your own internal IDP, then yeah, you can definitely continue to use federation if you wanted to. But, and the problem is, if you're using an external IDP, then it's more than likely that identity provider is also hosting authentication and authorization for other customers, which means they have a means of identifying you, and they have a means of knowing all the websites that you are connecting to that they host or serve. The privacy that was designed in the FIDO protocol is now lost. The relying party, the actual website owner who is receiving the user's connection after authentication and authorization, they don't know what other websites that user is visiting. But the IDP in the middle does, because the user is possibly authenticating to that same IDP for half a dozen different websites. What do you think happens when you go log in with Facebook, log in with LinkedIn, log in with Google? They're collecting all your information to the hundreds of websites that you visit. All the more to sell, right? Because they've got a profile of you now, and every time you log in with Facebook or Google or LinkedIn, user ID and password, you're giving them information about your life and what you're doing. Same thing can work with FIDO if you let them, but it breaks the privacy principle of FIDO. Where is the problem? The problem is GDPR and CCPA. These are the world's first privacy regulations that mandate that privacy is a fundamental right. The fundamental right words are in GDPR, Article 1 of the GDPR. CCPA is not so flowery, but there is a right to private action if information about the user is not encrypted. What does that mean? It means there is an implied responsibility to protect PII of that user, including their IP address or a digital signature of their browser that they use to connect to your particular website. If the IDP is breached, that user's information is now available to attackers. Who is liable? Is the IDP liable, or you, the website, who has contracted with that IDP to offload the authentication process? We don't know who is liable. If you are the relying party, the company or the agency who is relying on a third-party identity provider, you need to ask them, what happens if your database gets breached and the user's privacy is now compromised? And now there is a lawsuit from a group of users who opened up a class action against the company or the identity provider. You're now going to have to look at the contract that was signed between your company and that identity provider. Somebody is going to have to pay for that breach because now the law says somebody has to pay. The question is who? If the company that has implemented FIDO is directly authenticating the user to the website, the liability is still the company's, but at least they know what the potential is for a breach to their authentication system, which should hopefully be minimal because they're only collecting public keys and nothing else on their FIDO2 server. And even if it gets breached, there's nothing, no PII there. But an identity provider may be collecting a whole lot more than just a FIDO public key and a key handle. You don't know what they're collecting. They're not going to tell you what they're collecting and what they're doing with that information. All they're doing is guaranteeing you a service level agreement for the identity service that you have contracted for. So the privacy regulations are something you need to watch out for because it breaks the privacy principle, and now there is a way for users to go to court against some company, whoever that may be. In time, we'll find out. Lots of resources about FIDO2 on the internet. I'm going to send this presentation to the officials at ISSA chapter over here. There are links all over the presentation. Please feel free to click on them, and you'll be led to information that I think is very useful. That's it. I've got time for 2 questions. I know everybody wants to go home. And whoever's got those 2 questions, get this fabulous little stuffed toy. Ma'am, you're the first.
You said Bank of America uses this?
Bank of America implemented UAF years ago. And it only works on mobile devices. The problem is they did not put out a public release. I don't even know whether they notified their consumer base because I'm not a B of A customer.
So the breach in 2019 was not protected by the type they hadn't implemented.
My gosh, I didn't even know the B of A was breached in 2019. I keep track of so many breaches, but I didn't know that. I apologize, I don't know. More than, if they were using FIDO2, or FIDO, I would have learned about it because there would have been some mention of it on the FIDO mailing list to which I have access. I did not hear of it. But it's very hard to breach the FIDO protocol. Not just hard, I think it's extraordinarily hard. You're all familiar with the common access card that the DoD uses, smart card with digital certificates. You're familiar with the PIV card that the federal government uses. Guess what? FIDO is actually stronger than both of them. Yeah. Yes, it is.
Is there a list of the sites that have it that we can go to?
Someone is maintaining a off-FIDO Alliance website. I've seen it once. I'm happy to find it and send it to the ISSA chapter leadership. They were tracking every website that had implemented it. To the best of my knowledge, I know some of the big ones, but I don't know all of them. Yours, ma'am. Please pass it down to her, sir. Next question, this side of the room. Yes, sir.
So what happens if I have a USB key with all these credentials? I lose them. Would an adversary be able to get that USB key, let's say log on to Facebook, use that key and log into that website?
Very good question. Thank you. It depends on a number of factors. One, what type of a USB authenticator do you have? Does that USB authenticator require user verification? I've got 3 USB authenticators, but only one of them actually asks me to verify my identity with a biometric of my finger. The other 2, I just have to touch it. So technically, anyone can activate the private key on those 2 authenticators. But here's the thing. The attacker would have to know, first of all, I found what looks like a FIDO authenticator. How cool is this? Now, who could this belong to? Is it John Doe? Is it Mary Jane? Is it Donald Trump? I don't know. No, it's Jack Dorsey of Twitter. His password got hacked, remember? Sorry. If the authenticator requires user verification, then they cannot even activate the private key. If it does not require user verification, they're going to have to know the website that you have used it with. They're going to have to know the precise account name you use to identify yourself with that. Now, it only will work if they know all this and if it's a passwordless authentication. Originally, U2F was designed to be a second factor, which meant that it still preserved the username password, but you now also had to use this second factor. So Google, being the creator of U2F, Gmail still requires you to use a username password, but if you get yourself a security key, register it in your security page, it will now prompt you each time you authenticate to Gmail, even if you use a user ID password. FIDO relies on a whole lot of other things to protect you against FIDO2, the latest version of that. Is there a risk that someone will use your authenticator to log into your account? Possibly, but here is the thing. There is no leakage of information. The attacker can open this up, and if they have the knowledge and the capability to use an electron microscope or whatever to figure out what information resides in there, they're still not going to discover your username, because the username is not buried in here. It's in the key handle, which is typically an opaque blob only known to the manufacturer of the authenticator. And only the manufacturer of the authenticator knows how to decipher or deobfuscate that key handle to identify your particular username and recognize that it is your private key. So there are those controls. If you're paranoid, in the short term, you can implement FIDO2 with a user ID password. You don't have to make it a passwordless protocol if you don't want to. You can have them still authenticate with a username password and then ask for the FIDO2 digital signature. So now if there is a possibility of a loss of an authenticator, then you still have some protection. But remember, the protocol allows you to specify what type of authenticators you will accept for registration. If you define a security policy that says user verification is required, mandatory, then you will not be able to register a key on that website unless there is a biometric or a PIN or a password on their authenticator. The Android phone and the iPhone are likely to be the most common authenticator for I don't know how long in the future. Every one of us has a mobile device, and every mobile device supports biometrics, voice, PIN, Face ID, Touch ID, whatever. And there is a protocol in the FIDO suite of protocols that will allow you to log into a website on a laptop, but you're authenticating on your phone. Because the challenge that comes to the laptop is sent by the platform using a protocol called CTAP, Client to Authenticator Protocol, over Bluetooth or NFC to the mobile device, and now the challenge shows up on your phone. So as long as you have your phone and you've got it turned on with biometrics, the chances of losing an authenticator are very, very low. Thank you very much. Thank you all. Thank you.